Manigandan, you are able to see the screen. Problem number 3.
Yes, sir.
Okay. So today, in first unit, we are going to see the third problem. Okay. That is, yesterday we have seen two problems. Today we are going to see the third problem. That is, I will be reading out the question, then I will be explaining you the given data, then you have to write and you have to solve. Okay. Are you ready, Manigandan? Manigandan, are you on the line?
Yes, sir.
Okay. See, problem number 3, 8-cylinder automobile engine. You carefully have to read. 8 cylinder. So number of cylinder is 8. Okay. Of 85.7 mm bore. Bore is nothing but dia. Okay. 85.7 mm bore and 82.5 mm stroke. That is L. That is the distance the piston can move from TDC to VDC. Compression ratio, I think you might have studied in an automotive engine. Compression ratio, okay, is tested at 4000 rpm. 4000 rpm will be the engine speed. Compression ratio is, I think, how far in SA engine compression ratio will be less. CA engine, I can go for high compression ratio. Okay. SA engine compression ratio will be less, where CA engine compression ratio will be more. That is how far I will be able to compress the charge so that my expansion will be more. Okay. So engine speed is 4000 rpm, and we are doing test on a dynamometer. That is, it is having an arm that radius is 0.533 5 meter. Okay, that is a radius in order to find the torque. Okay, so what happens, I am testing my engine in a dynamometer. Okay, so what duration is, during 10 minutes test at dynamometer, my scale beam reading is 400 newton. 400 newton is force. Okay, 400 newton is force. 4.55 kg of gasoline, for which the heating value is 46,000 kilojoule per kilogram, are burnt. So see here, 4.55 kg, that is mass of the fuel, which is burnt for 10 minutes. Okay, that is for 10 minutes I am using 4.55 kg. And the heating value is 46,000 kilojoule per kilogram. And regarding here, the temperature have been given 294 Kelvin. And this one is pressure 10 into 10 power 4 Newton per meter square. What I am going to do is, it is going to supply to the carburetor. So you can understand it is a SI engine at the rate of 5.44 kg per minute. That is, it is a air rate. Okay, fuel rate you have to calculate. Air rate is directly given, 5.44 kg per minute. So what are the things you have to find is brake power, brake mean effective pressure. That is a BMEP means brake mean effective pressure. BSFC means brake specific fuel consumption. Then fourth one is specific air consumption. Then brake thermal efficiency. Then volumetric efficiency, air fuel ratio. So these are the things you have to find. Okay. So by going through this problem, you can solve any type of problem. These parameters have been asked. If any problem is asked related to brake power, brake mean effective pressure, and what are the terms listed, no, you'll be able to calculate. Okay, provided the given data should be there. So now I am writing the given data. See, first it is given 8 cylinder. So K, capital K is 8. So yesterday I told you K stands for number of cylinders. And D, some book for bore they will use capital D, and Some books they use D, small d. So now I am using a small d, that is 85.7 mm. And L is nothing but stroke, 82.5 mm. I am using small l. Some book will be using capital D and capital L. I am using small d and small l. And see, compression ratio 7 is given. This data we are going to use or not while solving, you will know. Sometimes what will happen, no, even though we are not using that data, they might be giving in the problem in order to confuse you. Okay, so compression ratio will be 7. Okay, it is tested at 4000 rpm. So engine speed is 4000 rpm. Okay, so see, zero point 0.5, that is a dynamometer radius. This will be used for finding torque. See, 0.5335 mm for time period 10 minute. Force is 400 Newton. How much fuel is going to consume? See, for 10 minutes, WF means weight of fuel consumed. See, in the VDDC, no, we will be using M for kg, but in vehicle dynamics and vehicle design and data characteristics, they will be using the notation W. You may think for W Newton may come, but as per the book standard, since we are going ahead with the book, we are using WF. Uh, if you are using M also, not a problem, but in order to go have a similar methodology with the book, we are using W. So in most of the VDDC books, you might have seen weight mass, that is a mass of the fuel is 4.5 kg per minute you have to find, but for 10 minutes it has given. So what you have to do is per minute 4.55 divided by 10, that will be 0.455 kg per minute. Okay, this 4.55 is for 10 minutes. Now see, for that fuel, what is the heating value? 46,000 kilogram kilojoule per kilogram. And air, we are supplying the air. This data is related to air. Okay, and the previous data is related to fuel. So now see, for air, temperature is 294 Kelvin. Pressure, see, 10 into 10 power 4 Newton per meter. And how much mass of air I am going to send? You can see WA, that is a mass of the air. 1 minute, for 1 minute, we are supplying 5.44 kg per minute. Okay, for air, directly they have given for 1 minute, so directly we can use where that is mass of the air per minute. It has been given directly, we will use in the formula, whereas here you can't use directly, it is given for 10 minutes, so you have to divide by 10 to get 0.455 kg per minute. Okay, now you have understood the given data or not? Only one is there. Maniganda Kannan, have you understood the data or not? Ilavarsan is not there. Now it is okay. See, actually, parallelly, Ganesh sir also is having class, so I can't increase my voice. Now, see, I'm testing. Now it is okay. You unmute and come. You unmute the call and come.
Sir,
Now it is okay.
sir,
Hmm? You are staying outside, huh? Okay, you come to chat box. Okay, you are traveling. Ah, okay, okay. Then you can listen the class, no? Reply in chat message. You can reply in chat message. You can attend the class, no? Okay, okay. Voice is okay because I can't increase my voice. Parallelly, another class is going on. Hmm? Voice is okay or not? You are able to. Okay. Then I will proceed. See, now all the data have been given. They are asking what? Brake power. So you have to find the brake power. So brake power formula, last class itself I taught you. 2 pi nt by 60,000. 60,000 is for kilowatt. Okay. So now what I'm going to do is, instead of n, I'm going to type the value. N is nothing but 4000 RPM. Okay. Engine torque. How to find the torque? With another student joined. Okay. So n I am putting 4000. For finding out the torque, we need what? Force into radius. So what I am doing is, force is 400 multiplied by R. R is 0.5335. Okay. So you have to find the answer for this. If someone is working, they may give the answer. Since you are traveling, you will not be able to do, I think. Okay. But next class, you give the answer. That is, without answer, we will see. Next class, what you are going to do is, I will be asking the answer from you. You have to tell. Okay. So you have substitute the speed value.
88.80, sir.
Oh, you are using calculator. Hmm? What is the answer? 8?
Yes, sir.
8.
88.80.
80. Good. Later we will check. Okay. Okay. Next, brake mean effective pressure. Brake mean effective pressure. Actually, yesterday I have told you one formula is there. Indicated power KPIP. That is indicated mean effective pressure. LA small n. Small n, if it is a 4-stroke engine, n by 2. 2-stroke, n will be n. Okay. So what I am doing is, the data is not given. That is a peculiar problem in VDDC. By reading the question, you will not understand whether it is a 4-stroke or 2-stroke. But we can assume, as a conventional problem, we will assume it is a 4-stroke, because 2-stroke engine will be used in uh, bikes only. That is a 4-stroke engine applications only more. So normally we will assume whenever the data is not given, we will go for 4-stroke. Okay. So brake mean effective pressure. First of all, I have typed what is the formula. See, in order to find brake mean effective pressure, there is a one formula relating brake power and brake mean effective pressure. That is, brake power can be found like this: 2 pi nt by 60,000. Otherwise, it can be found in this formula by using a pressure, that is the number of cylinder K into brake mean effective pressure into L into A into N by 2 divided by 60,000. Okay. So you can able to find like this also. So I'm using this formula to find PB. Okay. So I will be keeping PB here, and I will be taking the other terms to left hand side. You can see 60,000 into BB 4L A N. How it is 4L? No, let me explain you. First, for this I need area. Let me calculate area. So area is pi by 4 d square. What is that d? You see, bore. Bore dia will be 85.7. Okay. See here I given now D. Don't confuse with this radius. This one is dynamometer test. This will be used for finding engine torque alone. So how much it is? 85.7. It is in mm. So what you have to do? You have to convert into meter. 85.7. Okay. 85.7 e power minus 3, that is 10 power minus 3 square. You have to find the answer. If possible, you give the answer now. Otherwise, I will give 5 minutes time. Then you can give. Okay. Break mean effective pressure. Now, I will be using that area here. Now, see, K is 8. I have to find PB only. That is break mean effective pressure. L is how much? Stroke length. Go and refer. 82.5. That also should be in meter. But it is given what? In mm. So I'm converting into meter. Area you might have found from the previous formula. Okay. Speed is 4000 rpm. 4000 rpm. See, I have substitute all the values instead of PB. Okay. So now what I am going to do is I know BP. BP you have found out here 88 point something. So next step, see this 8 denominator 2. So 2 and 8 will be changing into 4. Okay. BP BP how much? 88. See, I am putting the unit kilowatt. Okay, you have to carefully listen. It is a kilowatt. So answer will be a kilo. I have been taking into account the 60,000 will be term for kilowatt. So not a issue. It will be Newton per meter square only. You no need to have any confusion. This 88.8 is taken into account kilowatt only. So unit will be Newton per meter square. Okay. So, just to substitute into the formula. That is, if I'm using this formula, it is understood that BP will be in kilowatt and mean effective pressure will be Newton per meter square. Okay. Since it is a kilowatt, you should not confuse. It will be kilonewton per meter square because for BP, I have accounted here 60,000. Okay. So now for LAN, L is what is L? 82.5 minus 3. Area you have to substitute, and n is 4000. Okay. So what is the value of a? You are able to find now.
Sir, e power 3, 10 to the power 3 whole square பண்றதுனால ஜாஸ்தியா வருது சார்.
Which one? E power minus 3. It will be less only.
Okay,
E
okay,
power
okay.
plus 3 means it is not at all possible. That type of cylinder is not at all possible. Okay. E power minus 3. I am converting
Oh,
to meter.
okay, sir.
Uh, what is the area? I will wait for 5 minutes. You try to find out A. Then BP, break mean effective pressure. Yeah, you try to find out.
A is equal to 5.8 into 10 to the power 3
5.8 e power
into
minus
minus
3.
3, 10 to the 10 to the power minus 3.
Okay. Unit will be what? Meter square. Okay.
Mm, okay, sir.
Later we will check. So you substitute the value of A here and try to find out mean effective pressure. You are doing, or otherwise we will proceed to the next topic.
சார் சார் நீங்க போடுங்க சார். நான் சைடுல கால்குலேட் போட்டோன்னே நானே சொல்றேன்.
ஓகே, நீ என்ன பண்ண, இப்போ கால்குலேஷன் பண்ண வேண்டாம். ஏன்னா நீ
ம்.
டிராவலிங்கில் போறியா, வண்டியில் டூ வீலரில் போறியா, காரில் போறியா?
கார்ல தான் சார் போயிட்டு இருக்கேன்.
சரி, நீ என்ன பண்ண, நீ ஹோட்டலில்
ம். இல்ல சார்.
நீ ஹோட்டல்னா ஒன்றும் பிரச்சனை இல்லை. வீட்டில் போயிட்டு கால்குலேட் பண்ண, அப்படியே லிசன் பண்ணிக்கோ. ஓகே
ஓகே சார்.
சரி, வீட்டில் போயிட்டு கால்குலேட் பண்ணி நீ என்ன பண்ண, நான் இதை உனக்கு அப்படியே நான்
ம்.
வாட்ஸ்அப்பில் அனுப்புவேன். நீ என்ன
ஓகே
பண்ணுற,
சார்.
அதை வந்து ஒன்றுத்துக்கும் நீ அதை கைப்பட எழுதி ஸ்கேன் பண்ணி எனக்கு அனுப்பணும்.
ம்.
சரியா? அதே
ஓகே சார்.
வாட்ஸ்அப்பில்.
ஓகே சார். ம்.
உனக்கும் ஒரு ப்ராக்டிஸ் மாதிரி
ஓகே.
ஆச்சு. சரி,
ஓகே சார்.
அப்படியே போய் ஒர்க் எப்படி சால்வ் பண்ணணும்னு சொல்லி தந்துடுவேன். நீ வீட்டில் போயிட்டு
ம்.
சால்வ் பண்ணி எனக்கு வாட்ஸ்அப்பில் வந்து அனுப்புகிறேன். ஓகே, எல்லாரும்
ஓகே
அனுப்புகிறேன்.
சார்.
சரி,
ம்.
ஓகே. நவ் வி வில் discuss about brake mean effective pressure. Already I told you have to find the area first. Then BP is equal to K BP PP L A N by 2. BP means it is a brake mean effective pressure, whereas BP means brake power. Okay, so using the brake power 88.8 kilowatt, I am finding what BP. So it unit may be Pascal, or you will be changing into, the value is more, you can change into kilopascal. Next is brake specific fuel consumption. Brake specific fuel consumption means this first of all you have to get the formula. Then for the formula, what we have to do, like that you have to think. Okay. So see, last class itself I have told you, BSFC means how much fuel I am going to consume for required power. B means I have to use brake power in the denominator. If it is I means I will be using indicated power in the denominator. Okay. So here what I am going to do, my unit is for WF, the unit will be in minute. Okay. Unit will be in minute. But what is the data I am having? No. He has given 10 minutes I am conducting a test on dynamometer. For 10 minutes, I am consuming a fuel of 4.55. Okay. I'm consuming a fuel of 4.55. So for 1 minute, how much fuel I am going to consume? So listen carefully. For 10 minute, 4.55. So for 1 minute, divide this fuel quantity by 10. So this will be 0.455 kg. Okay. So you have to should not supply 4.55 kg directly in this formula, then it will be wrong. Why no? It is for 1 minute, that is kg per minute only you have to substitute. This one is kg per 10 minute. Okay, so you have to convert into kg per minute. This one I can write kg per minute. Okay, so I will be going to this formula. I will be substituting 0.455 into 60. Brake power is 88. Whatever value you substitute, then you calculate. Value will be, yesterday class itself I have told, kilogram per kilowatt hour. Last class you might have seen. Okay, a brake specific fuel consumption is kilogram per kilowatt hour. Why H is not coming? H is coming like a box. So see here, brake power, it will be in kilowatt. My specific fuel consumption will be in kilogram per minute. So in order to convert that kilogram per minute, what I am doing? I am converting into multiplying by 60 so that it will be a kilogram per second. Okay, kilogram per second divided by kilojoule per second, it will be a unit will be kilogram by kilowatt hour. Okay, so last class, let me clarify here. So yesterday, this is unit 1. So yesterday I sent see kilogram per kilowatt hour. I have to use this unit brake because I'm using brake power now. So that only I referred so that the correct wording can give. So you have to use B. B stands for brake power. So you find out this answer. Okay. Now specific air consumption. Same formula BSFC. You write BSAC. Okay, brake specific air consumption. Instead of WF, you will be going for WA. That is a how much amount of air I am going to consume. But the value is given directly. See 5.44 kg per minute. Okay. So what I am going to do is I will be substituting that value alone. No need of conversion because it is given per minute. So WA is 8.44 and brake power is 88. So you can write the same unit kilogram per kilowatt hour. This symbol box is coming. No, actually it should be H. I don't know why H is not coming. Here it is coming, but for equation it is not coming. Okay, so first parameter brake power we have calculated, and second parameter brake mean effective pressure we have done, and third one brake specific fuel consumption we have calculated using this formula WF into 60 by BP, WA into 60 by BP. Okay, so you have to work out and you have to give the answer. Brake thermal efficiency. Fifth parameter is brake thermal efficiency. Already I told you, thermal efficiency always relate to how much amount of fuel I am going to consume. That is, it relates to how much chemical energy I am having. For that chemical energy, how much energy I am producing. Okay, so brake thermal efficiency will be, you can see in denominator, how much fuel I am going to consume and what is the heating value. Then brake power you have to use. The 60 stands for what? Because I will be substituting this weight of the fuel in kilogram per minute. Okay, then only the unit will tally. Brake power you substitute 88 kilowatt. If its brake power is in kilowatt, calorific value should be in kilojoule. Okay, whenever you are having any doubt in the unit, no, you substitute all the unit, cancel it, and find at last what unit is coming. Here, see, kilowatt watt. Okay. Here it will be kilojoule per kilogram. This kilogram and weight of the fuel kilogram will get cancelled. Here denominator minute will be there. I converted into second. So here kilojoule per second kilowatt. So numerator also kilowatt, denominator also kilowatt. So it will be cancelled and you'll be getting a brake thermal efficiency. Brake power 88, and you must have find out what is WF, that is for 1 minute. And 455 heating value, it is given in the problem 46,000. So try to find out this answer. 5 parameters we have completed. Brake thermal efficiency. Okay. Next is, if you're having any doubt, you can unmute and you can ask.
Okay, sir.
Okay. Now, volumetric efficiency. The last one, volumetric efficiency.
எனக்கு யூனிட் தான் சார் பிரச்சனையா இருக்கு.
யூனிட்டா? இப்போ யூனிட் I will explain you. See, for
ஆமா
this,
சார். ஒவ்வொரு இடத்துல மினிட், ஒவ்வொரு இடத்துல செகண்ட்,
how I
வாட்,
have
கிலோ
to
வாட், இதெல்லாம் தான் சார் கன்ஃபியூஸ் ஆகுது.
see, I will explain you. Okay. What is the unit for brake power? Kilowatt?
ஆமா சார்.
What is the unit for WF? I will be giving what? Kilogram per minute. Okay. Kilogram per minute. 60 மறந்துரு. இதே மாதிரி தான் எல்லா ஃபார்முலாக்கும் நம்ம போட்டு பார்க்கணும். Yeah. Calorific value unit என்ன? Go and refer. Kilojoule per kilogram.
கிலோஜூல்.
தான் போட போகிறேன். Kilojoule by kilogram. ஓகே. இப்போ இந்த கிலோகிராமும் இந்த கிலோகிராமும் கேன்சல் ஆயிருமா?
கேன்சல் ஆயிடும் சார்.
இப்போ வந்து கிலோ வாட் இங்கே இருக்கா? இது வந்து கிலோ ஜூல், இந்த மினிட் வந்து கீழே கொண்டு போயிரு. கிலோ ஜூல் பர், திரும்ப எழுதுறேன்,
கிலோ வாட் கிலோ ஜூல் பை பெர் மினிட்.
நான் இப்படி எழுதிடுறேன் உனக்கு புரியுற மாதிரி. கேஜி கேஜி கேன்சல் ஆயிடுச்சு. இப்படி இருக்குமா? கிலோ வாட்டு டிவைட் பை கிலோ ஜூல் பர் மினிட். ஓகே. கிலோ ஜூல் வந்து எப்போ கிலோ வாட்டாக மாறும்? இட் ஷுட் பி வாட்? கிலோ ஜூல் பர் செகண்ட் தானே? புரியுதா புரியலையா?
ஆமா புரியுது.
கிலோ ஜூல் பர் செகண்ட் இருந்துச்சுன்னா 2 யூனிட்டும் சேம். இது ஆக்சுவலாக என்ன வருது? கிலோ ஜூல் பர் மினிட். அதாவது 1 ஜூல் இஸ் 1 வாட் இஸ் ஈக்குவல் டு ஜூல் பர் செகண்ட் தான், மினிட் கிடையாது.
செகண்ட்.
ஆமாம். நமக்கு வந்து இதை வந்து கிலோ வாட் மாதிரி ஆகணும். அப்போ தான் எஃபிஷியன்சி டேர்ம் நோ யூனிட்னு வரணும். நம்ம ஆக்சுவலாக என்ன இருக்குங்க? கிலோ ஜூல் பர் மினிட். 1 மினிட் வந்து எத்தனை? நான் என்ன பண்ணுறேன் இப்போ?
60 செகண்ட்ஸ்.
60 செகண்ட். செகண்ட்னு போட்டுக்கோ. இந்த 60 தான் எங்கே போகுது? மேலே போயிருது. மேலே
டிவைட் ஆகல, கேன்சல் ஆயிடுது.
டிவைட் 2 டிவைடில் ஒரு கோடு இன்னொரு கோடு. உனக்கு புரியறதுக்காக இப்படி எழுதுறேன். மேலே போயிருது. இப்போ வந்து என்ன இருக்கு? கிலோ ஜூல் பெர் செகண்ட் இருக்கா? கிலோ ஜூல் பெர் செகண்ட் வந்து என்னது உனக்கு? கிலோ வாட். அவ்வளோதான். யூனிட் சேமாக வருது, கேன்சல் ஆயிடுது. இதே மாதிரி தான் என்ன ப்ராப்ளத்துக்கும் யூனிட்டை சப்ஸ்டியூட் பண்ணி நம்ம செக் பண்ணுவோம். ஓகே. இப்போ பிரேக் ஸ்பெசிஃபிக் ஃபியூல் கன்சம்ஷனா இதில் யூனிட் எல்லாம் சப்ஸ்டியூட் பண்ணினா யூ வில் பி கெட்டிங் கிலோ ஜூல் பர் கிலோ வாட் ஹவர். நம்ம ஏன் இந்த பி டேர்ம் போடுறோம்னா பிரேக் பவர் போடுறதுனால யூ ஆர் யூசிங் ஸ்மால் பி. இஃப் இட் இஸ் இண்டிகேட்டட் பவர் ஐ வில் பி புட்டிங் வாட் ஐ. ஓகேயா? சரி. நெக்ஸ்ட்டு வந்து வால்யூமெட்ரிக் எஃபிஷியன்சி கண்டுபிடிக்கணும். முதல்ல இதெல்லாம் பார்க்காத, நேராக வால்யூமெட்ரிக் எஃபிஷியன்சிக்கு ஃபார்முலாக்கு போ. இதுதான் ப்ராப்ளம் சால்விங் மெத்தடாலஜி. ப்ராப்ளம் இதை பார்க்கணும். இந்த டேர்ம்ஸ் என்னென்ன கேட்குவான்னு சொல்லி அப்படி ரிவர்ஸில் வரணும். ஓகே. வால்யூமெட்ரிக் எஃபிஷியன்சிக்கு நேராக ஃபார்முலா பாரு. வால்யூமெட்ரிக் எஃபிஷியன்சி ஃபார்முலா இஸ் பிஸ்டன் டிஸ்பிளேஸ்மெண்ட் டிவைடட் பை வால்யூம் ஆஃப் ஏர் யூஸ்ட் அட் இன்டேக் கண்டிஷன். வால்யூம் ஆஃப் ஏர் used at intake condition multiplied by 100. Okay, இதான் volumetric efficiency. So volume, in order to find volumetric efficiency, you have to find piston displacement and you have to find volume of air used at intake condition. Piston displacement volume, that is in IC engine you might have studied swept volume, VS, piston displacement volume. I can use Vs or swept volume. Formula is pi by 4 d squared into L. Okay, pi by 4 d squared into L. D stands for bore diameter. L stands for
Diameter.
stroke diameter. Okay, D stands for stroke diameter, and sorry, bore diameter. L stands for stroke diameter. Okay, so we will be getting this value. Okay, so what you are going to do is, it is not piston displacement, it is piston displacement volume. For piston displacement, what you have to do, I have to multiply this volume with how many cylinder, what stroke, and what is the speed. Then only you will be getting piston displacement, that is meter cube per minute you will get. Okay, I will explain you how you are getting. The bore diameter 85.7, bore diameter 85 points. So what I am doing here, so the formula I have taken from piston volume separately you find out. Now it is coming what, 85.7 e power minus 3 whole square pi by 4 d square area formula. Then multiply by L, you will get a volume, piston displacement volume. L is nothing but stroke. How much stroke? 82.5. So it is in mm. Convert into meter. So pi by 4, 85.7, 10 power minus 3 whole square into 82.5 in 10 power minus 3. Should not confuse. You don't put square for stroke. You have to put square for bore. So this one is piston displacement volume. Now from this, how I can find piston displacement for from minute. So what I have to do, I have to multiply this by speed, 4000 rpm. Okay, then I have to multiply by how many cylinder, 8. Okay, it is a 4 stroke, so 4000 by 2. Okay, let me check. Now I am going to give the values also, so that you can note down, because already it has been solved in the book. So you have to work out, that is without referring the book notes, you have to work out and you have to give the answer. Okay, so see, let us compare your answer. From first I am going to write. Okay, so for brake power, see, he has multiplied force into radius. So we have multiplied what, 400 into 0.35. The answer what is giving is 89. Later you can check. If it is not coming, you write whatever answer you are getting. Okay, 89.34 kilo.
88.80 sir.
Okay,
நான்
whatever it
கண்டுபிடிச்சது.
may be, later you can check. Now see, indicator pressure, that is a brake mean effective pressure. I should not say indicator pressure, because I'm using a brake power. I should say brake mean effective pressure. Okay, so they, what they are doing is they are calculating the area separately. You should not get confused with this, why 10 power 6 here, 10 power minus 3 is there, no, so 10 power minus 6, 10 power minus 6 coming to the denominator 10 power 6. So no need to see the problem solving methodology in the book. This one is very very simple and you will not make any mistake. Okay, so what brake mean effective pressure is given in kilopascal. Let me copy the value for 704 kilopascal. This is my second answer. First answer is brake power. Second answer is brake mean effective pressure. Then C, brake specific fuel consumption. What I have done is for 1 minute it is 0.45 455. So I am substituting this value. Uh, 88 we are putting now. Actually, he is getting 89. It seems. So even though it is 88, it doesn't matter. Plus or
சார்
uh,
சார்
tell tell me.
ஏரியா வந்து ஏரியா இஸ் ஈக்குவல் டு 5.76 into 10 to the power minus 3.
5.8 into 10 power minus 3. Okay. Already you told the area. Later you go to the house and check whether you break mean effective pressure approximately to this area value 700 something 700 to 710. Okay. Sometimes I exact answer of the book will not come. So now see brake specific fuel consumption. Okay. So what I am doing is the same formula. It is coming around 0.306. I am not working down. You have to work out and you have to use calci. Okay. I can't use calci because in the class itself, regular teaching itself, we will be writing the formula and we will be telling you how to substitute. You have to calculate and you have to give the answer. Okay. So now I will share this file. What you have to do is you have to work out and you have to check whether the answer is coming closer to this. Okay. So now see brake specific air consumption, same formula, but WA directly is given per minute. You can see here WA directly is given per minute, that is for 1 minute. So no need of any conversion. Okay. So it is coming what 3.65. This is the fourth answer. That is the fourth value he has asked. Okay. Next, brake thermal efficiency. See, 18 brake power into 60 formula. You no need to see this. Okay, if you are
3.66.
seeing this, you will get confused. In order to explain you well, I am typing and I am explaining you. Okay, so changes 89 into 60 calorific value is getting what 20 point. Since no one is working out, I am taking the answer from the book. Last class, Elaverson has told the answer. Okay, 25 point.
0.255
Okay.
sir.
So now see volumetric efficiency. Let it be.
சார் எஃபிஷியன்சில வந்து இன்டூ 100 பண்ணாதான் சார் நீங்க சொன்ன ஆன்சர் கரெக்டா
Very
வருது.
good. I didn't put 100. The yesterday also,
0.255.
yesterday itself uh, it is understood efficiency. By putting percentage, I have to multiply by 100, but I have to show. I can't neglect it. Okay, good. So now you have to find out what is the piston displacement volume. That is pi by 4 d squared L. See, pi by 4 d squared L. It is coming in meter cube per cycle. I am explaining you how much it is coming 4.76.
சார் how much d value sir?
Huh? TD
d
pi
value
by
and r value sir.
I have written here. No, see, let me. I'm going to copy this here. Okay, copied. No. Hmm. So see, this one L.
Sir 4.75 into 10 to the power minus 4 sir.
Pi by 4 d squared into L. Okay, this answer will not come. Whereas this one will be equal to. Hmm, this one will be equal to. Volume answer will be here equal to.
4.75 into
Uh,
10 to the power minus 4.
okay, let me present it well. We will take this in the next line. Okay, this will be looking good. D I am putting what 87, 85.7. 10 power minus 3 multiplied by L. L is
Multiply with 82.5 into 10
82.5,
to
10
the
power
power
minus
minus
3. That you should not forget, okay? It is in the formula, so that only it is creating problem. Hmm. So what I am going to do, what is L value, man? 82.5, yeah?
82.5 into 10 to the power minus 3.
No, no, no. I am asking about stroke. See, don't, this only I am explaining. See, pi by 4 d squared into L. Square will come for bore only. Okay. So pi by 4, 85.7, 10 power minus 3 square multiplied by length. Length is nothing but a stroke. Okay. 82.5 e power minus 3. E power minus 3 because converting into meter. The unit will be meter cube per cycle. So answer what I am getting is 4.77. Correct?
4.75, sir. Into 10 to
4.75.
the power minus 4.
Okay. Good. 4.75 into 10 power 4. See, now I will explain this value. D unit is what? Meter square. Because you have converted mm into meter. L unit is meter. So meter square into meter,
Meter cube.
you will get meter cube. This per cycle, not it related to time. For one cycle, my piston displacement volume is this much. Okay. Now I am going to find for entire operation of my engine what is my piston displacement. So this is the formula. That is, I have to multiply the with the number of cylinders and stroke, four stroke. See, 476. No, I'm multiplying. See, so now I will simplify this. Instead of writing this much value, I will write directly my piston. Now I think it will be comfortable for you to see. See the formula. I have to multiply the piston displacement volume into number of cylinders, that is 8, and into 4 stroke. No, this 4 is sorry. In order to avoid this only, he is writing 10 power 6 in the denominator. If I am putting 10 power e power minus 4, I have to put bracket. Otherwise, I will think 4.75 e minus 4. Here it is bracket, it is understood, it is 10 power minus 4. Okay. So it is a value for piston displacement value and multiplied by number of cylinder, that is 8, and it is a 4 stroke engine. I am assuming it is a 4 stroke engine. So my n will be 4000 by 2. See, what is the meaning of this? No, for 4 stroke, we are finding for a cycle. This one is for a cycle, and since it is a 4 stroke, we have to divide the speed by 2. For 4 stroke, number of power stroke, you have to find n by 2. Okay. So 4.75 e power minus 4 into 4000 by 2 into 8. You find out this answer. This is piston displacement. Okay. So no need to see what he has done now. 4.75. Again he has taken to 475 and changed it into e power minus 6. No,
7.6.
okay, you no need to refer that one. You follow our own method. If this, you can follow your own method also for representing, but ensure that it is correct. So now what will happen? Now the main thing, this is meter cube per cycle. Here I am multiplying with the speed RPM, revolution per minute. One revolution will be one cycle. Okay, I'm multiplying for that speed and for number of cylinder. So this one will be the entire piston displacement. So what I am going to do is this unit will be meter
Meter cube.
cube per minute. Okay, and now you no need to see this. Just for seeing the answer only I have taken. Unit should be always in small letters. Okay.
Okay, sir.
Okay. Since it is equation piston displacement 7.62 meter cube per meter minute. Okay. Now I'm going to find volume of air. Why, you may ask why we are doing like this, because for finding out volumetric efficiency I need both term, piston displacement, volume of air used at inlet condition. This one I have explained you, volume formula, multiplying it by speed and number of cylinder. Since it is 4 stroke, I am dividing the speed by 2. So that is the logic. Here I have to find volume of air. You may ask how you are getting this formula. In thermodynamics, you might have studied PV equal to MRT, ideal gas equation. For finding out V, what you will be doing? MRT divided by P, correct? You are able to understand? V
Yes,
is
sir.
equal
Yes,
to
sir.
MRT by P.
Divided by
So the
P.
same formula only I am using here. You might be seeing for instead of M, I am using what? WA.
WA.
Okay. So I am going to substitute this value. WA is given how much per minute? 5.44. R is a gas value. You should know that. 287 or 0.287 kilojoule per kilogram Kelvin. So here I am putting 287. Okay. Then only the unit will be looking at tally. I will be explaining you how. What is the unit for temperature? What is the value? Unit is Kelvin. You have to go and you have to refer 294 Kelvin. Okay, everything data is given in the problem. Same problem will come, data will be changed. Instead of 85 as a bore, they will be putting 90. That's all. Okay. P is pressure. He is given what? 10 e power 4 Newton per meter square. Okay. 10 e power 4 is that kind of P. Okay. Now it is okay. 10 e
Yeah.
power 4. So now I will explain you. You will be getting one answer for this. Before that,
4.59.
4.59.
59
Okay. This
volume
unit also will be meter cube per
meter cube
minute.
per.
Okay. Let me explain you why, how, by using this formula, how we are getting a meter cube per minute. Okay. I'm going to explain you. You see, let us see his answer. He's getting 4.56. You are getting 4.5, not issue. See, I'm going to explain you the unit. See, denominator is pressure. Unit is what?
Newton per meter. Newton per mm.
Newton per meter square. Okay. W
Pressure
is
Newton per mm தானே சார் வரும், மீட்டர் ஸ்கொயர்னு வரும்.
இல்லை, அதாவது both units are correct. Depending upon strength of material போயிட்டேன்னா நியூட்டன் per mm ஸ்கொயர். பட் இன்ஜின் ரிலேட்டட் டேர்ம்ஸ் பார்த்தீங்கன்னா இட் வில் பி நியூட்டன் per மீட்டர் ஸ்கொயர் தான். அதாவது இப்போ ஒரு குவான்டிட்டியோட லென்த்து ஜாஸ்தியாக இருக்குது அப்படின்னுச்சுன்னா யூ வில் பி யூஸிங் அ மீட்டர், ஸோ தட் த வேல்யூ வில் பி லெஸ். The same quantity length is very very small, I will use the unit mm. Say for example a shaft diameter is 50 mm means I will say 50 mm. I will not say 50 into 10 power minus 3 meter, that is 0.05 meter. So our conventional notation only. So most of the cases related to thermal side will be using pressure Newton per meter square. Let me explain you why we are using. It is given data itself Newton per meter square. Okay. Now see WA. WA, you know the unit. I am just cancelling and typing the unit. Okay. WA is kilogram per minute. Okay. This minute only is going to come here. What about gas constant value? 287. You should not use 0.287. Then it will be kilojoule. Okay. So see, it is 287. So joule per kilojoule Kelvin. That is very, very important. Joule per kilojoule.
Into Kelvin.
I will, what I will do is kilojoule ah, joule per kilogram. Okay, not kilogram, because it is a specific heat, similar to specific heat, joule per kilogram per Kelvin. Normally, we will be using what? Kilojoule. What about this 294
Kelvin.
Kelvin?
Temperature.
Okay, so now see this Kelvin. Carefully see this Kelvin and this Kelvin will be getting cancelled. Okay, understood carefully. Kelvin,
kg
Kelvin
kg
getting
cancel.
cancelled, and this one
Kilogram
kg,
kilogram.
kg cancelled. Okay, so now we will
Joule
be
per minute.
having. You are able
Joule
to
per minute
understand?
divided by
Let me
Newton per meter square.
type it again. Kilogram cancel. So whatever red terms, I am deleting it. Okay, red terms. So now see, I have to bring the. I let me take the meter square up because Newton per meter square. No, meter square will going out, and Newton per meter square. Instead of that,
Joule meter square divided by Newton meter.
let me. Now you
Newton
are able
into
to
minute.
understand. It is Newton per meter square. It is going to the numerator meter square
Joule meter square.
multiplied by joule, and this minute is coming down. Later it will be clarified. Okay, so Newton into minute instead of joule. What is joule? Work done. Work done is nothing but force into distance.
Distance.
So force is Newton. I'm instead of joule, I'm putting what?
Newton meter.
Newton. Very good.
Meter.
Newton into meter. So this Newton.
Newton cancel. Meter cube divided by
Newton.
minute.
You are able to understand? We are getting the
Yes, sir.
value now. If instead of putting joule per kilogram per Kelvin, if you are putting kilojoule, then the unit will not be correct. That is, it will be coming what? 10 power 3 meter cube per minute. Like that, it will come. You are able to understand now? So that only what I am putting now.
Meter cube
287.
per minute.
That is meter cube per minute. For getting meter cube per minute, the gas constant value, that is R, it should be 287, not 0.287 kilogram. So like this, you have to work out in the rough page whether you are getting the answer. This and all basic. Okay. Okay. For understanding how you got this formula, MRT by P. Okay. So now you substitute the value for finding out volumetric efficiency. Okay, I'm typing here. What is piston displacement? 7.62. 7.62 meter cube per minute. Volume of air is 4.59. So you have to understood the formula. That is volumetric efficiency is equal to piston displacement divided by volume of air used at intake condition. 7.62 meter cube per minute divided by 4.59 meter cube per minute. Okay, so find out the volumetric efficiency. The same formula, same method can be adapted for all the problems. Okay, you are substituting this value. You are able to find now volumetric efficiency. How much? 60. You are getting or not? Check. This is one answer. My volumetric efficiency is 60%. Okay. So see, first one brake power. He has asked see
சார் வால்யூம்ல
one,
வந்து
two.
டோட்டல் வால்யூம் டிவைடட் பை பிஸ்டன் இருக்கு சார். அந்த பிஸ்டன் டிஸ்பிளேஸ்மெண்ட் 4.59 டிவைடட் பை 7.62 இருக்கு சார். அந்த நீங்க இன்னொரு காமிச்சதுல.
Oh, I have entered. Very good. I have changed the value. Nice. Always volume of air, piston displacement, volume of air. Let me
60.23%.
wait. Volume of air is so volume of air will be coming in numerator, correct?
Yes sir.
So I have typed it wrongly. Okay, always volumetric efficiency, soft volume only will be coming down. Mistakenly, I have typed wrongly. So please correct it. Don't repeat this mistake. It is a
60.23%.
previous mistake. Okay, you should not change the numerator and denominator. Let me correct. So volumetric efficiency formula, again you correct it. It is volume of air used at intake condition divided by piston displacement. Okay. So 4.59 divided by 7.62. Check whether you are getting 60. Good.
60.23%.
You are getting 60. We will proceed the last topic, air fuel ratio.
Sir,
Getting the answer 60%.
60.23%.
Okay, no problem. Now, the last one is air fuel ratio. Air fuel ratio is mass of air divided by mass of fuel. You remember this term. Air fuel ratio
Okay sir.
either on mass basis or either on volume basis. Okay.
சார் எனக்கு
So,
அப்புறம் சார் எனக்கு ஒரு ஹெல்ப் வேணும் சார். இப்போ ஃபர்ஸ்ட் யூனிட்ல வந்து நம்ம என்னென்ன ஃபார்முலாலாம் படிக்கிறோமோ ஃபார்முலா மட்டும் தனியா எனக்கு வேணும் சார் நோட்ஸ்னு.
அது நான் என்ன பண்றேன், after completing first unit, I will summarize all the formula and I will give it to you. Okay.
ஓகே சார்.
Okay,
ஓகே
I
சார்.
thought of completing the first unit today by completing the two problems, this problem and next problem. But next problem, I think I will be able to take in the next class only because it will be taking more time.
ஓகே சார்.
No, I will be able to complete it is less only because the same concept only. We will be able to complete, not an issue because we are having half an hour now. So we will be able to complete. By today, I am completing first unit and I will be sending the formula through WhatsApp
ஓகே சார்.
tomorrow or before next VDDC class. Okay.
Okay,
Now
sir.
see air fuel ratio, mass of air divided by mass of fuel. Either it can be on mass basis or it can be on volume basis. Okay. Air, if I'm saying A by F, mass of air should come on numerator and F mass of fuel should come in the denominator. If I'm saying F by A, mass of fuel should come on the numerator and A should be coming on the denominator. So you try to find out what is the air fuel ratio.
11.95.
11, huh?
11.95. 11.95.
Okay, good. 11.96. So see, this is the very uh, lengthy problem. This is a lengthy problem and it will involves calculation of most of the parameter. When you are able to solve this problem, any model related to this, only they will be changing the values, but concept will be simple. Okay. For example, see air fuel ratio is given mass of air and mass of fuel. If mass of air is not given, you can't find volumetric efficiency and air fuel ratio. So they will ask up to break thermal efficiency. They will not ask volumetric efficiency as well as air fuel ratio. Okay. If MA, that is WA, is not given, volumetric efficiency and air fuel ratio we can't find. Okay. So problem will be simplified. But this problem include all the values. So complication, that is a lengthy problem, and if you're able to solve this, you'll be able to solve all the types. See how much parameter he has asked: brake power, brake mean effective pressure, brake specific fuel consumption, specific air consumption, brake thermal, volumetric efficiency, air fuel ratio. It didn't ask about indicated power. Why no? Mechanical efficiency is not given. If mechanical efficiency is given, we can find out what indicated power also. See, I am not using this value. Compression ratio 7. Okay, compression ratio 7. I am not using it. So you go through this problem. Brake power. We have found out brake mean effective pressure. Very easy. Okay, brake specific fuel consumption. These are the formula. What you have to do? You have to take this formula separately and you have to learn specific air consumption, brake thermal efficiency, volumetric efficiency, and at last volumetric efficiency. You correct my mistake. Okay, that is initially I have typed it wrongly. It is volume of air used at intake condition divided by piston displacement. Okay, so an air fuel ratio. So this is the one of the most important problem. Shall we proceed to the next problem? Manigandan, shall we proceed to the next problem?
Yes, sir.
Okay. It will be simple only. Just I will be explaining you the step. Okay. So it is assumed that a automobile engine can operate at thermal efficiency of 22 percentage. Okay. So it is given uh, uh, my automobile engine thermal efficiency. So immediately I'm writing the given data. This is the correct. By reading one sentence, you write the given data. Efficiency thermal 22. Operating condition given. Volumetric efficiency C 80. Mechanical efficiency 82. Eating value of petrol. Eating value of petrol is 46,400 kilojoule per kilogram. HV.
Calorific value.
Calorific value. Both are same. Then see now only is giving one not to confuse you. He has given one statement. Already you know for burning 1 kg of fuel we require 14.5 kilogram of air. But he is saying the same thing what we are knowing is giving in the problem. Theoretical air required per kg is that is in theoretical basis, not on practical. That is when you are driving a motor vehicle for 1 kg of petrol, you will not use 14.5. It may be either more or it can be less. Theoretical calculation, we are putting what 14.5. That is, if I am operating in this condition, no emission, and I am getting full power, my efficiency also will be good. Okay, we can't say full power. Efficiency will be good. Okay, then excess of air, that is Compared to this, I am using air more, that is 25% air more. Okay, so now petrol vapor, he has given petrol vapor as a density twice the density of air. See, for density I am using the symbol rho. Rho v means fuel vapor, that is petrol vapor. Rho v is equal to 2 into rho a. Okay, rho v is equal to 2 into rho a. Okay, it is given now. Vapor as density twice that of density of air. And at the end of the suction stroke, the pressure is how much? 8.24 into 10 power 4. See, I am writing here. In order to understand, I am writing in a bracket suction. That is at the end of the suction. You can, if you want, you can write end of suction so that it will be more clear representation. Okay. So pressure at end of suction, then T is 333 Kelvin, and R you see 287. What I have done is I have, it is 287.14. What you have to do is you have to find the cylinder dimension. Cylinder dimension means bore stroke. Okay. Actually, number of cylinder is how much? 6. See, capital K is 6.
6 cylinders.
Brake power is how much? 66 kilowatt. Brake power is 66 kilowatt. Speed is 4200 rpm. Speed is 4200 rpm. And you have to find that is, you have to fix the stroke and diameter, that is L is 25% greater than D. That is always diameter will be less, stroke will be more. If the diameter and stroke is same, we will say it is a square engine. Okay, you remember this term also. Now, in our case, stroke is greater than dia. Okay, so you can see thermal efficiency, volumetric efficiency, mechanical
25%
efficiency,
greater than dia.
calorific value. Okay, so everything is given. How to find the solution? Okay, so now what I am going to do is, starting from scratch, I will explain you how to solve. Then you have to give the answer. I will give some 10 minutes time. So what you have to do is, first we have to find indicated power. Okay, indicated power is equal to brake power by mechanical efficiency, because I am having what? Brake power is given, mechanical efficiency is given. So go here, substitute. What is a brake power? 66 kilowatt. So my input power also, indicated power also will come 66 kilowatt. Mechanical efficiency how much? 82%. But for putting, you have to put 0.82. So try to find out indicated power. So once indicated power, you substitute this value indicated power here. That is
80.42.
how much you are getting?
Indicated power is equal to 8
80.
80.48.
Okay. I am writing the value. So for answer, you can highlight. Okay. So whenever answer anything you are getting, no, you can underline it with the pencil. Now see, I have found out indicated power. I need how the problem is going. You have to see. Okay, first I will explain this. What is going to do? No, at last we have to find bore and stroke. I will give one idea to you. Bore and stroke can be found when we are knowing volumetric efficiency, because in volumetric efficiency we are having the formula pi by 4 d squared L. So you will be able to find either D or L, because L and D relating relationship is given. Okay, so you have to find volumetric efficiency first, and in from that you have to find D and L. For finding out volumetric efficiency, there is another formula. Instead of using this, VA by VF divided by VS. So for this VA and VF, we are calculating this. Actually, volumetric efficiency is given. The volumetric efficiency is given. If the volumetric efficiency is not given, you will not be able to proceed this problem. Okay. So at last, this logic should come into picture. For finding out D and L, volumetric efficiency is given. So what you have to do is, in the numerator, we have found out what last problem, what we have found out, the volume of air used at intake condition, we have to find. Okay. So using this volume of air used at intake condition. See, last problem, only air we are using, but here we are using both air and fuel. Let me explain you. So now, in order to proceed that logic, what you have to do is you have to calculate how much quantity of fuel I am going to supply. It is not given in the problem, but we know that thermal efficiency,
calorific
the
value.
thermal efficiency is given. So immediately you are in your mind, see, first one, mechanical efficiency is given. So you have to think from with the mechanical efficiency, and with this data, what I can find. I am having brake power, I am having mechanical efficiency. So with this I can calculate indicated power. So I have calculated my indicated power will be using somewhere, but you calculate first. Later you will realize where we will be using indicated power. Okay. Next, thermal efficiency is given. With this thermal efficiency, what I can do now, you will be getting idea. Thermal efficiency, I know one formula, ip into 60 by wf into hv. I have found ip using mechanical efficiency. I can find my wf, because when wf is there, I can use it in my volumetric efficiency to find out bore and stroke. Like this you have to think. Okay. So for finding out WF, we are going for indicated thermal efficiency. Indicated thermal efficiency is given how much? 22 percentage. Okay. So you put
Point zero point
0.22.
two two.
Calorific value how much? 4, 6. Okay. Indicated power, you are given the answer 80.48. Whatever
Zero
value,
point
or
four seven.
what will be the unit? You tell me.
எஃபிஷியன்சிக்கு நோ யூனிட். ஐபிக்கு வந்து
It is a volume, it is like a mass of fuel. Even though the symbol is a
ஆமா,
WF, it is mass of fuel.
இண்டிகேட்டர் பவர் வந்து கிலோ
No need
கிலோ
to
வாட் பர்.
substitute the unit and find out. By common sense, you can tell that is a
மாஸ்
weight of the
கிலோகிராம்.
fuel and kilogram. It's kilogram per minute. Okay. Previous problem we
அப்போ
have seen
ஜீரோ
now.
பாயிண்ட் ஃபோர் செவன் கிலோகிராம் பர் மினிட்.
See why no? 60 is there no? So it is what? Kilogram per minute. Okay. So kilogram per minute. What is the answer?
0.47.
0.47. Okay. Now you know that how much air theoretically required is 15. Sorry, 14.7. Even though it is not given, you should be knowing it. Stoichiometric ratio. It is given 14.5. So I am putting 14.2. Actual weight of air supplied, WA, will be
14
what?
point.
Tell me. 25% more, no? So you
Twenty-five
have to,
percentage more than diameter.
yeah. Let me check the answer. Indicated power C, it is coming 80. Very good. Your answer is good. Weight of the fuel 0.47 kilogram per minute. Okay. Now see, theoretically, I required air, that is air fuel ratio 14.5 multiplied by 0.47. Okay. I will explain this. Yeah, I am having a doubt in that, so that only I have referred. See, last problem I have explained, I am taking this only. Listen carefully. I will be including another step here. This problem is somewhat tricky. See, air fuel
As
ratio
fuel
is equal to
ratio.
what?
14
Manigandan, are you
point.
listening?
Yes, sir.
Air fuel ratio is mass of air, mass of fuel. Instead of M, I can write W also. WA WF. Okay, this one you have to know. Either mass basis only, but here kilogram per minute. This data also I can use. So what he is doing is understand the logic clearly. Directly I can't find weight of air, but he has given air fuel ratio is how much? 14.5. That only is given. That is for is correlating the data. That is for 1 kg of fuel burning, I need a 14.5 kg of air. So it is a air fuel ratio. That is a fuel is 1 kg, air is 14.5. For us, how much fuel it is coming? 0.47. Okay, I'm putting 0.47. So 0.47 is the fuel amount. Now what you have to do? How to find the weight of air?
.81.
Even though I'm using weight of air, don't get confused. Unit will not be Newton. It is what? Kilogram per minute. That is a VDDC point of view.
6.81.
So, okay, 14.5 into 0.47. How much?
6.81 kilogram per minute.
6.81 kilogram per minute. Okay. What is telling no? This is the theoretical air required based on air fuel ratio. But we are supplying some excess air. See, he is supplying excess air. So compared to this, I am supplying 25% more. So what I will do is I will multiply this by 1.25. Otherwise, I will find out 25% and I will add with this. Okay. So see, it is given you are getting 6.85 is 6.81. So you have to multiply this by 1.25 because I am supplying 25% more. So this is very, very important. How to put the one, why I am putting 1.25 now? 25% more. If I am saying 30% more, you will put what? 1.3. You put 6.1. What will be the answer? Try to find out.
8.51
8.51. Unit will be what?
kilogram
Same. Kilogram
kilogram
per
per
minute.
minute.
Now see, I know what is the weight of
சார்
air.
சார் இப்ப இப்ப 60% மோர்னு இருந்தா 1.60 போடணுமா சார்?
1.6. Correct. Very good. அதாவது எக்ஸாக்ட்
சைடுல ஹிண்ட் மாதிரி போட்டுருங்க சார்.
இங்க போட்டிருக்கேன் 1.25 இன்ட்டுன்னு போட்டிருக்கேன்.
அது இல்ல சார், அந்த 25%க்கு நம்ம 1.25 போடுறோம், சைடுல ஒரு ஹிண்ட் மாதிரி லைட்டா எழுதுறீங்க
அதுவா
சார்.
ஓகே, வெரி குட், நைஸ் சஜஷன். ஓகேயா, இப்போ புரியும் நினைக்கிறேன். முன்னாடியே போட்டேன் எக்ஸஸ் ஏர் 25. இப்போ நான் என்ன
எஸ்
பண்ணேன்,
சார்.
வாட் ஐ எம் கோயிங் டு டூ இஸ் ஐ எம் கோயிங் டு ஃபைண்ட் வால்யூம் ஆஃப் ஏர் supplied per minute at intake condition. இது சேம் ஃபார்முலா the previous we have used to know for finding out volume. PV is equal to MRT. Volume of air I am going to find. Then I will be finding volume of fuel also. So I will be substituting now. WA is how much? 8.51 R 287 multiplied temperature given 333 Kelvin. All this data is related to what? For air. If this data is not available, we can't find volume of air. So that only see this data is given. TR at the end of suction only we need. So it is given what? 8.24 e power 4.
Into 10 to the power 2.
Now you find density of air, then it is given density of our fuel, that is petrol vapor, will be 2 times of density of air. Let me explain, then you proceed. Okay, so from this formula, sorry, this one is
volumetry, volume
This
of
is
air,
one. This is volume.
density of
I
air
have
இல்ல, volume of
interchanged.
air.
Yeah. Wait, wait.
Volume
Let
of
me
air
copy
is
this.
equal to
No, density formula is there. Let me explain you. Okay. What I have to do is
density வந்து mass by
I have
volume
to. You tell me the answer. This one. No
9.87
need to get
kilogram per
confused.
minute.
I didn't see it is a density.
Okay, sir. 9.87 kilogram per minute.
Volume of air you are
Meter
getting
cube
how
per
much?
minute.
9 point.
9.87. 87 meter cube per minute.
Let me check. 9.94. You are
Meter
getting
cube தானே, minute
9.5.
வராதா?
Okay, it is a meter cube. Okay. Now what I
9
have to do
points, sir.
is
9 points.
see. I need I need to find similarly. I have found VA. No. Okay.
Sir, 9
Understand.
points, sir. 97
Okay.
9
I
points.
have written 9 points. Good. See, listen. I have found out VA. Okay. Now, similarly, I have to find VF. For
Mm,
me, I am not bothering about density of air. But
mm.
for finding out the VF, I need some values. For fuel, I don't have this data. I have to find it in the another way only. For that, I'm using the term density is equal to mass per volume. When mass of the fuel is known and density of the fuel also known, I'll be able to find volume of the fuel. So the same logic only I'm going to use. So it is like a twisted problem. Okay. For that, he has given one int. Density of the fuel is equal to 2 times the density of air. So since the data is given, I'm finding the density of air. Density of the air is mass per unit volume. What is the mass? Here I have 8.51 mass divided by volume. That is kilogram per meter cube will come. So find out this answer. What is density of air? Unit will be
0.877.
0.8777 kilogram per meter cube. Okay. Now, density of petrol vapor, what you have to do? You have to multiply this by 2 because it is given in the problem. Go and see.
1.75.
Let me see here. It is given, see, petrol vapor as density twice that of density of air. Okay. 2
இந்த
into
கண்டிஷன் வந்து எல்லா
8.
சம்முக்கும் கான்ஸ்டன்டா இல்ல இந்த சம்மோட இது மட்டும் தானே சார்?
இந்த சம் தான் இருக்கிறதுல கொஞ்சம் காம்ப்ளிகேட்டடான சம். அதாவது நிறைய யூ ஹேவ் டு திங்க்
அது
இட்
ஓகே
மோர்.
சார்.
போன சம் வந்து டைரக்டா சப்ஸ்டிடியூஷன் பண்ணி வந்துடலாம். இதுல எதுக்கு
ம்.
டென்சிட்டி கண்டுபிடிக்க போறோம், எதுக்கு நம்ம வால்யூம் கண்டுபிடிக்க போறோம், எல்லாம் அந்த கடைசியில இருக்கும்போது தான் நமக்கு தெரியும். ஓகேயா?
அது ஓகே சார். இப்போ வந்து டென்சிட்டி
ஓகே. நவ்
கண்டுபிடிக்கிறதுக்கு
வாட்
வந்து
இஸ்
இது
த
வந்து
வேல்யூ
ஸ்டாண்டர்ட்
ஆஃப் டென்சிட்டி?
ஃபார்முலாவா சார்?
டென்சிட்டி வந்து நம்ம இந்த ஃபார்முலா தானே. டென்சிட்டினாலே மாஸ் பெர் வால்யூம் தான். டென்சிட்டி
அது ஓகே
மீன்ஸ்
சார்.
ஹவு
இப்போ நம்ம
மச்
பிஎஃப்
மாஸ்
வந்து
இஸ் தேர் இன் த
கண்டுபிடிக்கணும் சார்.
வால்யூம்.
டென்சிட்டிய
ஓகேயா?
டென்சிட்டி ஆஃப் ஃபியூல் கண்டுபிடிக்கணும்ல சார். அதுக்கு இது
டென்சிட்டி ஆஃப் த
கான்ஸ்டன்டான
ஃபியூயல் வந்து
ஃபார்முலாவா இல்ல இந்த சம்முக்கு
density
மட்டுமா
of the
இது?
let me explain you. Density of the fuel வந்து you can't find it using this formula. That is actually I doesn't need density of fuel. I need volume of the fuel. Volume of fuel கண்டுபிடிக்கிறதுக்கு I can't use this formula because I need R of the fuel, T of the fuel, P of the fuel, but I don't have that. So what I am doing is I'm going to find V from rho. So first of all, it is given rho of F is equal to 2 into rho of A. ஸோ ரோ ஆஃப் ஏ கண்டுபிடிச்சிட்டு டென்சிட்டி ஆஃப் ஏர் கண்டுபிடிச்சிட்டு ஸோ டென்சிட்டி ஆஃப் ஃபியூலை அதுலேருந்து கண்டுபிடிக்க போகிறேன். இந்த ஆன்சர் என்னப்பா? 2 into 0.877
1.75
1.75
கிலோகிராம் பெர் மீட்டர் கியூப்.
கிலோகிராம் பர் மீட்டர் கியூப். ஓகே. ஓகே. நவ் வாட் ஐ எம் டூயிங் இஸ் இப்போ தான் பாரு, நான் இப்போ மெயின் இதுதான் எனக்கு தேவையே. ஐ ஹாவ் டு ஃபைண்ட் வால்யூம் ஆஃப் பெட்ரோல் வேப்பர். வால்யூம் ஆஃப் ஏரை நான் இந்த ஃபார்முலா யூஸ் பண்ணி கண்டுபிடிச்சிட்டேன். பட் ஃபார் வால்யூம் ஆஃப் ஃபியூயலில் வந்து ஐ கான்ட் யூஸ் திஸ் ஃபார்முலா because I don't have data related to fuel. Weight of the fuel I have found out. How much? 0.47 kilogram. Density of the fuel 1.87. 0.75. So now you find
0.26 meter cube.
0.6.
26.
Ah?
26.
Okay.
26.
26. Then volume. Okay, unit வந்து meter cube. Let me
0.26 sir. 66 இல்ல 26.
26. Let me check the value. Okay, it is correct. Now I will explain you how to do. You are going to find now. This part, entire part, I will explain you. I will give time. You find out. See, the last problem we have found out what piston displacement volume. Okay. First of all, I will explain you. Volumetric efficiency equal to volume of air used at inlet condition by piston displacement. So based on volumetric efficiency only, I am going to proceed with this problem. You take this volume. Volumetric efficiency is given 80%. Okay. Volumetric efficiency is given 80%, 0.8. Total soft volume per minute, that is piston displacement volume. Formula is last problem itself I have told you. Pi by 4 d squared L into n by 2 number of cylinder. Instead of number of cylinder, I can put K. What you have
Sir,
to do?
இப்போ more than 2 cylinder இருந்தாலே n by 2 தானே sir?
More than 2 cylinder, இது வந்து based on stroke. 4
சரி
strokeனா n
stroke
by
sir.
2, 2 strokeனா n. இது வந்து
3
n by
stroke னா sir?
நம் 2 stroke 4 stroke தான் உண்டு, 3 ஸ்ட்ரோக்லாம் கிடையாது.
இல்ல கொஸ்டின்ல 3 ஸ்ட்ரோக்னு கொடுத்திருந்தது.
இல்லை அந்த அளவுக்கு காம்ப்ளிகேட்டடாக நமக்கு வரல. அதுக்கு வந்து நம்ம
ம்.
we have to go through the research. இந்த இது டிவைஸ் பண்ணாங்க தெரியுமா, அந்த ஃபார்முலா டெரைவ் பண்ணாங்கல்ல,
ம்.
அவங்க கிட்ட தான் நம்ம அதை இது பண்ணணும். அதை நான்
ஓகே
பார்த்து
சார்.
சொல்கிறேனே. ஓகே,
ம். ஓகே சார்.
இந்த டெரிவேஷன் பார்த்தா தான் தெரியும். இப்போ என்னால் அதை ரிமெம்பர்
ம்.
பண்ண முடியல. பார்த்துட்டு
ம்.
சொல்கிறேன்
ஓகே
நான்,
சார்,
ஃப்ரீயாக
ஓகே சார்.
இருக்கும். ஸோ இந்த ஃபார்முலா வந்து பார்த்தீங்கன்னா பை பை 4 டி ஸ்கொயர் எல் இன்ட்டு என் பை 2 இன்ட்டு நம்பர் ஆஃப் சிலிண்டர். நம்பர் ஆஃப் சிலிண்டர் உனக்கே தெரியும் எவ்வளோ, 6. அப்படியே இதை சப்ஸ்டியூட் பண்ணு. இதில் ஒன்றே ஒன்று நீ செய்யணும், என்னென்னா D and L தெரியாது. You have to find D and L. So what you have to do is, first you find L. L வந்து equal to 1.25 D. So you replace L by 1.25 D. அப்போ என்ன வரும்? D cube வருமா? So D கண்டுபிடிச்சிட்டு அதுக்கப்புறம் L கண்டுபிடி. I am not going to show this because due to time constraint, I will show here. See here, what he is doing, pi by 4 d squared L into n by 2 number of cylinder. Number of cylinder 6. n by 2 2100. n வந்து எவ்வளோ?
4200.
அதான் 4200 by 2 2100. ஓகேயா? சரி, இப்போ இந்த எல்லை வந்து நான் என்ன பண்ணுறேன், டி ஸ்கொயர்டு இருக்குது, எல் இருக்குது. எல்லுக்கு பதிலாக என்ன போடுறேன், 1.25 டின்னு போடுறேன். அப்போ என்ன ஆகும், எனக்கு ஒரே ஒரு அன்னோன் தான் ஆயிரும், 1.25 டி கியூப். ஓகே, இது போட்டேன். இது அப்படியே இங்கே வச்சிருக்கிறேன். நியூமரேட்டரில் வால்யூம் ஆஃப் சார்ஜ், இப்போ பார்த்தீங்கன்னா இது வந்து ஒரு கார்பரேட்டட் இன்ஜின். முன்னாடி பார்த்தது டீசல் இன்ஜின், உள்ளே வர்றது ஏர் மட்டும்தான். ஓகே, திஸ் ஒன் இஸ் அ கார்பரேட்டட் இன்ஜின், தட் இஸ் அ எஸ்ஏ இன்ஜின். போத்
ஏர் ஃபியூல்
ஃபியூயல் அண்ட்
மிக்சர்.
ஏர் வில் கம். நீ கேட்ப, போன இதில் நீங்கள் இது பண்ணலையேன்னு கேட்பீங்க, ஒன்லி விஏ தானே கன்சிடர் பண்ணீங்கன்னு. இது வந்து நம்ம இன்ஜினோட பேசிக் தெரியணும்.
பெட்ரோல் இன்ஜின்.
எஸ்ஏ இன்ஜின், எஸ்ஏ இன்ஜின்ல என்ன வரும், போத் மிக்ஸ் ஆகி தானே
பெட்ரோல்.
வரும்.
ஏர்
ஆமா,
ஃபியூல்
அதாவது
மிக்சர்.
கார்பரேட்டர் இருந்துச்சுன்னா விஏ பிளஸ் விஎஃப் வரும். ஓகே, நான் என்ன பண்றேன், விஏ விஎஃப் ஆட் பண்ணிக்கிறேன், 9.94 இதுவும் ஆட் பண்ணிக்கிறேன். இது யூனிட் வந்து மீட்டர் கியூப்ல இருக்கு. எனக்கு வந்து இங்க இதை வந்து நான் எம்எம்ல வச்சிருக்கிறேன். அதனால என்ன பண்றேன், மீட்டரை எம்எம்மா மாற்றும் போது 1 மீட்டர் இஸ் ஈக்குவல் டு 10^3. ஸோ 10^3 இன்டூ 3 வந்து என்னது 10^9. இதுதான் நான் வச்சுக்கோ. ஓகே, அதர்வைஸ் யூ கீப் திஸ் அஸ் மீட்டர், இதை வந்து நம்ம எம்எம்மா மாற்றணும். இதுதான் ரொம்ப ஈஸி நமக்கு. ஸோ விஐ விஎஃப் நம்ம கண்டுபிடிச்சது மீட்டர் கியூப். யூ ஹவ் டு கன்வெர்ட் இன்டு எம்எம் கியூப். ஒய் நோ, we are going to find D and L in mm. That is in this formula நான் என்ன அசியூம் பண்ணியிருக்கேன்னா, my D what I am going to use, it is in mm. D பொறுத்து தான் இந்த யூனிட் வரப்போகுது எனக்கு. அதனால D is in mm நான் ஃபிக்ஸ் பண்ணிட்டேன். இப்போ D mm இருக்கும்போது நியூமரேட்டரில் வால்யூமும் நான் மீட்டர் கியூபாக இருக்கிறத mm மாற்றுறேன். ஓகே, 10^9 இதை அப்படியே போடுறேன். 0.8 கொடுத்துட்டாங்க, இதை அப்படியே சால்வ் பண்ணுறேன். டி கியூப் ஈக்குவல் டு சம்திங்னு வரும். டி என்ன வரும்னு பாரு, 1/3 இது எழுதி வச்சுக்கோ. D வந்து 101 mm should come, and after getting the D you multiply D with 1.25, then stroke will be 126. Okay, இதான் problem. It is a most complicated and tricky problem. You have to think more. அதாவது வால்யூமெட்ரிக் எஃபிஷியன்சியை யூ ஹவ் டு யூஸ் இட் லாஸ்ட். ஆன்சர் எழுதி வச்சுக்கிட்டியாப்பா?
ஓகே சார்.
வால்யூமெட்ரிக் எஃபிஷியன்சியை வச்சு தான் நம்ம கண்டுபிடிக்க போகிறோம். அப்படியே நான் லாஸ்ட்லேருந்து உனக்கு ப்ரொசீட் பண்ணுறேன் பாரு. வால்யூமெட்ரிக் எஃபிஷியன்சியை வச்சு தான் ப்ரொசீட் பண்ண போகிறோம். வால்யூமெட்ரிக் எஃபிஷியன்சியில் டினாமினேட்டர் கண்டுபிடிக்கிறதுக்கு இந்த ஃபார்முலா. இதில் ஒரே ஒரு அன்னோன் வந்து டியும் எல்லும் மட்டும்தான். அதை ஒரு ரேஷியோ வச்சு டி குப்பா வச்சுக்கிறேன். மேலே கண்டுபிடிக்கிறதுக்கு விஏ விஎஃப் தெரியும். விஏ விஎஃப் கண்டுபிடிக்கணும். முதல்ல விஏக்கு போகிறேன். விஏகே வந்து நான் கண்டுபிடிக்கணும்னா டபிள்யூஏ ஆர்டி, ஆர்டிபி தெரியும், டபிள்யூஏ தெரியாது. அப்புறம் டபிள்யூஏ எப்படி கண்டுபிடிப்பேன்? அப்படியே மேலே போகிறேன். டபிள்யூஏ கண்டுபிடிக்கிறதுக்கு இதுவே கிடையாது. டபிள்யூஏ தெரியணும்னா ஏர்ஃபியல் ரேஷியோ கொடுத்துருக்குறான். டபிள்யூஎஃப் கண்டுபிடிச்சாதான் டபிள்யூஏ கண்டுபிடிக்க முடியும். அப்புறம் டபிள்யூஎஃப் எப்படி கண்டுபிடிப்பேன்? டபிள்யூஎஃப் கண்டுபிடிக்கணும்னா ஏதாவது தெர்மல் எஃபிஷியன்சி கொடுத்துருக்குறான். அப்போ இந்த டைமில் டபிள்யூஎஃப் தெரியணும், எனக்கு கண்டுபிடிக்க முடியும். இதை வச்சு தான் கண்டுபிடிக்க முடியும். இதை நான் கண்டுபிடிக்கணும்னா எனக்கு இண்டிகேட்டட் பவர் தெரியணும். அப்போ முன்னாடி வந்தால் ப்ராப்ளம் இங்கே தான் ஆரம்பிக்குது. அதுக்காக தான் லாஜிக் இப்படியே பின்னாடி போகுது. ஸோ முதல்ல இண்டிகேட்டட் பவர் கண்டுபிடிக்கிறேன். அப்புறம் இண்டிகேட்டட் தெர்மல் எஃபிஷியன்சிலேருந்து டபிள்யூஎஃப் கண்டுபிடிக்கிறேன். அப்புறம் டபிள்யூஎஃப்லேருந்து டபிள்யூஏ கண்டுபிடிக்கிறேன். அப்புறம் டபிள்யூஏலேருந்து விஏ கண்டுபிடிக்கிறேன். அப்புறம் இங்கே இன்னொரு ட்விஸ்ட் வருது. விஏலேருந்து விஎஃப் எனக்கு டேரெக்டாக என்னால் கண்டுபிடிக்க முடியாது. அதுக்கு தான் நடுவில் ஒருத்தன் வரான், டென்சிட்டி. ஏன்னா டென்சிட்டி ஆஃப் ஏர் எனக்கு தேவையே இல்லை. ஆனால் இருந்தாலும் டென்சிட்டி ஆஃப் வாட்டர் வேப்பர் ஃபியூல் வேப்பருக்கு தெரிகிறது வந்து என்னது 2 இன்டூ டென்சிட்டி ஆஃப் ஏர். ஸோ டென்சிட்டி ஆஃப் ஏரை வந்து நான் இங்கேருந்து கண்டுபிடிக்கிறேன். மாஸ் பர் யூனிட் வால்யூம் போட்டுட்டு டென்சிட்டி ஆஃப் ஏர் கண்டுபிடிச்சிட்டு அப்புறம் டென்சிட்டி ஆஃப் பெட்ரோல் வேப்பர் கண்டுபிடிச்சி இப்போ டென்சிட்டி வந்து என்னது மாஸ் பை வால்யூம். மாஸ் டபிள்யூஎஃப் நான் முன்னாடியே கண்டுபிடிச்சிட்டேன். ஸோ மாசு பர் வால்யூமா, வால்யூம் வந்து என்னது மாஸ் பர் டென்சிட்டி கண்டுபிடிச்சிடலாம். ஸோ லாஜிக் என்னன்னா டிஏயும் விஎஃப்பும் கண்டுபிடிக்கிறது தான் இவ்வளோ ஸ்டெப்பு. அதை கண்டுபிடிச்சிட்டு கீழே வந்து டிஎல்ல டி கியூப்னு போட்டு, அதாவது இந்த 2 அன்னோன் இருக்குது, அதை ஒரு அன்னோனாக மாற்றிடுறேன். எப்படின்னா கொடுத்துருக்கான் ரேஷியோ என்ன சொல்லியிருக்கிறான்? டி இஸ் 1.25 டேர்ம்ஸ் ஆஃப் ஸ்ட்ரோக் இஸ் 25% greater than diameter. That is my L is 1.25 D. ஓகேயா? ஸோ நீ ஆன்சர் எழுதி வச்சுக்கோ. இந்த ஆன்சர் வருதான்னு பாரு. ஓகேயா? ஸோ ஃபர்ஸ்ட் யூனிட் ஓவர். ஓகே, எனி டவுட்ஸ் ஏதாவது இருந்துச்சுன்னா நான் நெக்ஸ்ட் கிளாஸ் கேளு. என்னப்பா? ஓகேயா?
ஓகே சார். இப்போ வரைக்கும் டவுட் எதுவும் வரல சார்.
நீ என்ன டவுட்னாலும் நோட் பண்ணிக்கோ. நெக்ஸ்ட் கிளாஸ் நம்ம கேட்கலாம். ஓகேயா?
ஓகே சார். தேங்க்யூ சார்.
தேங்க்யூ.